All right, so Claire or Claire and company. Let's say I add 5. What's going to happen to the original graph?
Let's start on 5 on the y-axis. Starts 5 paces up.
So everything's up 5 units. It looks like it just moved 5 up, right? Does that make sense? Remember the original one in case you need it? There's the original. Here it is for the second one. Okay? Make sense? So now let's go. What is this going to do?
It's going to move it 3 down.
3 down. There's the original. Here's the new one. Looks like it is definitely 3 down, right?
Wait, why am I just getting a straight line?
I don't know.
I think you can see your calculator back there.
Next question.
It's hilarious. I'm dying.
What is this going to do to the graph? Moves it left. Okay. There's the original.
There's the next one. Or right. Whoa.
It actually moves it right 3.
That's wild.
Okay.
Why does it do right 3 if it's minus?
It's a good question.
Oh.
It's imagine you're setting it equal to 0 and solving for x.
What? Oh, okay. Got it.
See what I'm saying?
Yeah.
Okay. And so what would this do if I do plus 4? Left 4. Okay.
Subtract.
So there's the original, there's the new one. Do you guys see those 4 rules? Okay, so let's write them down in our notes. Okay?
I have no. So I have 12, and then I have the y one. X parentheses plus 5. And I press and then
I couldn't say no because I wanted to
You're going to have to equal sign. Still thinking. Still thinking.
yeah.
Oh. Because your axis is zoomed in a little bit, and so you weren't able to see it because it was so.
Oh.
It should come in now. Is it coming in?
Oh, okay. Yeah. Thank you.
Alrighty. So in your notes, let's just start right here. Okay. If I add outside of the function, was it a vertical, meaning up and down, or horizontal, which is left and right movement? Vertical. And was it up or was it down when I'm adding on the outside? Okay, do you guys see how I'm filling this out?
Yeah.
Okay. When I have f of x and then I subtract k, also vertical, the only difference is it goes down. Okay? When I add something in the parentheses, those are now horizontal shifts because we're going left or right. And if I add, which way do I go? And if I subtract, it's right. Okay? Any questions on that? Okay? So, before I talk about these, let's just go to example 1. Okay? What we're going to do here is identify the parent graph in each one. Okay, so there's some stuff going on here. We have a -4 and a +2. But what do you see in here that tips away what the shape's going to look like? So we want to be thinking x cubed to start. Okay? Just normal x cubed. What about here? just the square root of x, then that graph. And over here it would be 1 over x. Okay?
What is the word next to that?
Parent, parent, parent. These are the parent graphs. Okay? So next, let me get a pencil. Oh no. Do I really not have pencils in here? My pencil, there it is. Okay. So let's do this one together. Okay. If you know the parent graphs really well, this is very easy to do. A lot of people have a hard time with this section because they just don't remember the parent graphs. Okay? All this stuff that you see in front of you, the -4 and the +2, the +3 and the -1, and all it does is take your parent graph and move it. Okay? And it's always the same rules. It doesn't matter what the parent graph is. Okay? It could be a square root, it could be a cubic, it could be a function you have never even heard of yet. It's always going to follow those rules that we just talked about. Okay? So I'm going to start by graphing just the regular x cubed graph. 0 cubed is 0, 1 cubed is 1, -1 cubed is -1, and I know it looks roughly something like that. Yes? Now, let's write down what kind of shifts there are. So this -4 means I'm going to move which way? Right 4, and this +2 means we're going to go up 2. Does that make sense? And that just means take your entire graph and move everything, right 4 up 2. So if I took this point right here, I can go right 1, 2, 3, 4, and then go up 1, 2. Follow the pattern. And so here's the final graph. Okay? Any questions on how I'm getting that? Okay, why don't you guys try the next one? See if you can get the correct picture here.
How would you know which one would take you right and which one would take you left? Oh, no. Oh,
Hold on. Is that all I have to say? And then it makes sense? You just know.
Just now.
Got it. Okay. Does it make sense?
yeah, no.
Okay. Okay.
Yeah.
Okay, if you really understand these graphs and you have the shapes pretty familiarized, it shouldn't take you too long. And now look, do you have to draw the parent graph and do it all in all those little steps? Not necessarily. If you see what's going to happen and you understand where it's all going to end up, that's fine. Okay? But if you have a hard time knowing that, like, when I look at this, I know that my graph is going to be, oh, I lied. Start down here, and then it's going to look something like this. Okay? Did you guys get that? Do you want to go through it step by step? Okay. So let's start from the beginning. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So the parent graph is just the square root of x. Okay? And I know that the graph for the square root of x looks like this. Okay? If you don't know that, it's going to slow you down. Okay? You got to make sure you start memorizing these. But worst case scenario is you just plug in points until you can figure out where they go. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is a decimal, which I don't know, and same with the root of 3. But the square root of 4 is 2. Does that make sense? And so there's my graph. Okay? And now what is going on according to these numbers here? What am I doing?
Just gonna move to the right now. You're left 3 and down 1.
Left 3,
Down 1.
down 1. So do that with everything. Does that make sense?
Yeah.
Your starting point goes left 3, down 1. This point also goes left 3, down 1. And then this point also goes left 1, 2, 3, and then down 1. So your final graph is going to look something like that. Okay? Does that make sense? Before you guys leave, please make sure there are no shards of candy cane laying around. All right. Let's do this one together because this one always throws people off. So 1 over x. Let's draw that first. I know the 1 over x graph is the one that has the asymptotes. And the parent graph looks roughly something like that. Okay? Here's what I would recommend if you want to not screw this one up, because this one's kind of tricky. Do you guys see where the center of this graph is, basically? What would the coordinates for, like, the center of the graph be?
The center of the whole thing.
Yeah, the center of the picture. Where is
0,
it?
0.
0, 0. What's going on at 0, 0? Well, the two asymptotes meet there. Does that make sense?
Okay.
Do you see what I'm saying? Now, do you guys see where this point is in relationship to this point?
Yes.
It's just 1 over and 1 up. Does that make sense?
Yes.
Over in this direction, it's the same thing. It's 1 over and 1 down. Okay? In relation to the center location. You guys with me? Okay, so now what is this going to do and what is that going to do? Left 2, good, and up 4. So rather than do everything, here's what I'm going to do. I'm going to start with this center point because that's going to be a good reference for my picture. This point is going to go left 1, 2, and then up 1, 2, 3, 4. Okay? So this little circle that I just filled in, that is the center. That is where the asymptotes meet. Does everybody understand that? Okay, and if you get that much, how do you fill in the graph? Well, now you would just go 1 over and 1 up from that location, 1 over and 1 down from that location, and you just draw that shape right in. Okay. Does that make sense? Okay, I know we use the calculator to kind of get a feel for how these move and how they look. This entire stuff that we're doing right now, all of it is without a calculator. Okay, when we take the exam. Okay, so just make sure you keep that in mind. All right, let's turn the page. Let's do example 2 together. All right, so here we're filling out a table. Here are my x values. I'm trying to figure out the y values, and all I have is the picture that goes with it. Okay? So Ryan, what would the output or the y value be when x is negative 5? So at negative 5, we're down here at negative 5, is what you're saying. It's at 0. Okay. You guys see how we did that?
Yes.
Okay. Let's see. Miguel, what would negative 4 give us?
Negative 2.
Good. Let's go. Claire, what would 0 give us?
3.
Good. Christian, what about 4? What's 4 going to give us?
0.
Good. And let's go back. Julia, what about 8?
4.
Okay, good. Everybody good with how we're getting those numbers?
Yeah.
Okay. Now, if you paid attention to these rules that we talked about, you could probably figure it out without having to actually move the graph every single time. Okay? So let's talk about what is going to happen to the picture. If I have plus 2, what happens to the picture there? It goes up 2. Okay? So what if I subtract 2? Okay. What if I do minus 2 in the parentheses? Good. And this one would be good. Okay, so let's go through this table. Okay? If this is your parent graph, or f of x, right? Imagine everything got shifted up 2 units. Okay? What variable do you think of when we say up? So that means all my y's are going to increase by 2 units. Does that make sense? So what are the new coordinates going to be at all of these locations?
2, 0, 5, 2, 6.
What?
Does that make sense?
Yeah.
Okay. Here my y values are all going to
Go down to
decrease by 2. So go back to the original parent graph and decrease everything by 2. What do we get? Negative 2.
Negative 4. 1. Negative 2. 2.
Make sense? Okay. Now, over here, when I'm moving right or left, which variable do you think of?
X.
So x is going to change, right? The y's are going to be exactly the same as they were before. Only the x's are going to change. Does that make sense to everybody? Okay. And so now let's think about this. If I'm moving to the right 2, does that increase the x or decrease the x?
Increase.
Increase. So if I increase everything by 2, my new x coordinates will be
2. 2. 6. 10.
10.
Does that make sense? Okay. Here it's the same thing. Go back. Well, here are the original x values. We shift everything left 2, so now the x's will decrease by 2. So this will be
Negative 7.
-huh.
Negative 6. Negative 2. 2. 6.
Is this making sense?
Yes.
Okay. Try example 3 on your own. Okay? It's literally just a single point instead of a whole table, but it's the same concept. So if this is the parent point or on the graph of h of x, where's the new point going to be when you look at each one of these 4? So take a minute and see if you can figure those out. All right, let's start going through these. Jason, just tell me. I don't care about the answers yet, but just tell me where everything's moving in all four of these. So what does this do to the graph? If you Oh boy.
This is to the right.
Leslie, help us out. Which
Your name was
Mine's up one.
up one, and then what about this the second one?
Going to the right.
Good. Third one,
Down 7.
and then
Left 6.
good. All right, let's try this again, Jason. And no, I'm not going to have you just read these to me. What I want you to do now, here's the original point. What are the new coordinates if this gets bumped up a unit?
3, 9.
What if I move it right 3 units?
0, 8.
Good.
3, 1. I don't know. I'm not having a brain fart. 9, 8.
I'm a little frightened for his destiny next semester. Are you guys okay?
Yes.
Okay. One more and then we're done. Okay. Example 4.
Oh,
So here's the parent graph. We'll just do this one together. We're talking about x cubed. What would this equation have to look like if it actually gets shifted left 7? So instead of x cubed, it would be what?
X squared.
squared.
X cubed. X
X
plus 7.
minus moves it right.
Oh,
So this would be plus 7 cubed. Does that make sense? Okay. What would it have to be if the x cubed graph is actually shifted up 3 units? Oh.
Would be
Parentheses,
X in the
and
parentheses.
you.
Plus 3.
Wait, what
I'm
are
hearing
your
different.
parentheses around
If it was in parentheses, then it would move left and right.
No, isn't the X just in parentheses?
Oh, like this?
Yeah.
Sure. Yeah, that works. Yeah, that's fine.
Oh.
That's the same thing. What if it's moving to the right? What would it be?
X minus 4 parentheses cubed.
Good. And then down 5 would be?
X parentheses cubed minus 5.
Good.
Parentheses, I got this.
Making sense? Okay. No homework or anything. But again,